Today in the second lecture of the lecture series on digital electronics, we would learn about different number systems and their representation. We should understand how data can be represented using different number systems before starting with digital electronics. Binary number system and digital codes are fundamental to computers and to digital electronics. This lecture introduces the representation of decimal, binary, hexadecimal and octal number system. Binary and hexadecimal are the popularly adopted number systems in digital electronics, which we would frequently use in further lecture classes. Let us understand what is called a radix or base of a number system. The number of independent digits used in the number system is known as radix or base of the number system. For example, decimal is a radix 10 number system. It has 10 different digits or symbols such as 0, 1, 2 up to 9. Any number higher than 9 can be represented using these 10 digits. Similarly, for binary, it is a base 2 number system which has 2 digits such as 0 and 1. Now in case of a hexadecimal, it is a base 16 number system and the 16 digits are comprised of 0 to 9 and A, B, C, D, E, F. The 6 English characters represent 10 to 15 respectively. That means 10 is represented by A, 11 by B, 12 by C and so on. Octal has radix 8 including digits from 0 to 7. So for a radix R or base R number system, the digits are 0, 1 up to R minus 1. Let us discuss what is positional or weighted number system. The traditional number system which we have discussed, those are decimal, binary, hexadecimal and octal, these are positional number system. In such a number system, a number is represented by a string of digits where each digit position has an associated weight, and the value of a number is a weighted sum of all the digits. For an example, let us consider a number 1734, which is a base 10 number. Now this particular number can be written as 1 into 1000 plus 7 into 100 plus 3 into 10 plus 4 into 1. Here we can say weight of 4 is 1, 3 is 10, 7 is 100 and weight of 1 is 1000. Similarly, for another example which is a decimal floating point number, let us say the number is 568.23. This particular number can be represented in its weighted form as 5 into 100 plus 6 into 10 plus 8 into 1 plus 2 into 0.1 plus 3 into 0.01. So in general, a number capital D of the form small d1, d0, point d minus 1, d minus 2 has the value d1 into 10 to the power 1 plus d0 into 10 to the power 0 plus d minus 1 into 10 to the power minus 1 plus d minus 2 into 10 to the power minus 2. Let us solve few examples. The first question is express the decimal number 106.58 as a sum of the values of each digit. The same question can be asked in a different way. Express the decimal number 106.58 as a sum of the products obtained by multiplying each digit by its appropriate weight. 106.58 can be represented in its weighted form as 1 into 10 to the power 2 plus 0 into 10 to the power 1 plus 6 into 10 to the power 0 plus 5 into 10 to the power minus 1 plus 8 into 10 to the power minus 2, which can be written as 1 into 100 plus 0 into 10 plus 6 into 1 plus 5 into 0.1 plus 8 into 0.01. So here we can say that the weight of digit 1 is 100, digit 0 is 10, digit 6 is 1, digit 5 is 0.1 and digit 8 is 0.01. The second question is, what weight does the digit 7 have in each of the following numbers? And the numbers are 1370, 6725, 7051, 58.72. Now the answers can be over here. 1370, the weight of 7 is 10. In 6725, the weight of 7 is 100. In 7051, weight of 7 is 1000. And in case of 58.72, the weight of 7 is 0.1. Let us discuss one example each from other number systems to know the weighted structure representation. Let us start with the binary number system. The example considered over here is 1011.01. Now, to represent this particular number in its weighted structure form, it can be written as 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0 plus 1 into 2 to the power minus 1 plus 1 into 2 to the power minus 2. Similarly, the other examples, such as in case of hexadecimal, a number f1, a2 can be represented as f into 16 to the power 3 plus 1 into 16 to the power 2 plus a into 16 to the power 1 plus 2 into 16 to the power 0. An example from octal number system, the number is 436.7. It can be represented as 4 into 8 to the power 2 plus 3 into 8 to the power 1 plus 6 into 8 to the power 0 plus 7 into 8 to the power minus 1. For a base 4 system, let us say the number is 233. It can be represented as 2 into 4 to the power 2 plus 3 into 4 to the power 1 plus 3 into 4 to the power 0. So in this lecture, we have discussed about representation of number system. In the next lecture, we will discuss conversion from one number system to another number system. Hope you have liked the video. If you have any doubt or you want to give your opinion regarding the lecture, please write it in the comment section. If you feel that this video will help any of your friends, then please do share this video. If you want to watch the other videos in this lecture series, then subscribe to the channel and do not forget to press the bell icon for the notifications. Thank you very much for watching the video.